year you talked about all of these translations. So if I had you show me with your arms x squared, and if I had you go x squared plus 1, what would it do? Go up 1, right? What if I'd said minus 1? Go down 1. And you did all that. You remember all those? You left, right, and all that good stuff. But it was fine until you got to stretches and shrinks, right? That if you had a 2x in you remember the nightmare of all those? And how many of you are still confused about what this does? 2x quantity squared versus 2x squared. How many of you are confused on those? Those are still confusing to you. Yeah. So wouldn't it be great if you just didn't have to worry about it at all? That's what we're going to do today. You don't have to worry about what happens where with the stretches and shrinks. We're going to do what we call a point translation. We're going to move the points instead of moving the functions. And so you move a couple of points and you can draw the function, right? And what I like about this is I can make this incredibly complicated, but it's still the same two ideas. And the two ideas are you're either inside the function or you're outside the function. Those are the two possibilities. You're either inside the function or you're outside the function. So let's say we have this unknown function. I don't even know what it is. Maybe it's x cubed, maybe it's x squared minus x cubed. I don't know. But with this function, something's going to happen in the x direction. This inside has to be equal to a new x, the new translated x, okay? And let's see here. I'm going to say that again. This is the new x. We're going to translate it to the old x. So the old x is 5. So I'm going to write 5 here. And you're going to find the new x. So algebraically solve for that. What do we do to both sides? Add 4. And so 3x is equal to 5 plus 4, which is 9. What's x going to be? The new x. 3. So this translated is going to be 3 something. So one more time, this is equal to the old x. We can find the new x by solving for x. It's kind of an inverse thing, isn't it? Kind of an inverse thing. Now the new y is you take the old y, and what is f of x the same as? When I said f of x, I meant which variable? Y, yeah, okay. So here is where my old y is. This is, I shouldn't write it there because it looks like it's the answer here. This is the old x, and this is the old y, and we're going to translate it to the new x and the new y. Well, the new y is you're going to take the old one. Anything that's in here, in this box, that is the old y. And you're going to take 5 times the old y and add 6. So essentially you're going to multiply it by 5 and add 6. Well, what was the old y again? 8. So I go 8 times 5 is 46. So 346 is the point that's translated using this formula. Done. Did you have to learn the up and down, the left and right, the stretch and shrink? Did you have to learn those? No. You just have to know this inside equals the old x, take the old y, and do the outside operations to it. Let's do a couple more. Let's do this one. I could make up any parent function I want. Let's say it's x minus 12 cubed. But forget about that for right now. Let's just take these old points, old x and old y, And let's make a new one. I'm going to highlight the part that is inside the function. Come on, here we go. There's the inside part. So for the new x, you're going to have the old x, 14, is equal to 6x minus 4. Then what's x going to be? What's that going to be? 3 again? By the way, it's not always 3. It just happened to be this time. So you take the inside, set it equal to the old x, and you're going to get 14 equals 6 out of 3. So this is going to be 3. Now, take the entire y. The entire y. And now we're going to find the new y by taking 14 minus 2 times the old y. And what's the old y? From the point that we're translating. 8. Yep. So 14 minus 16 is going to be negative 2. So there's the translated point. What do you think? Can you do this? I think you can. But you got to prove it to me. Translate this point. Okay, we got a class answer of 2, negative 6. We're going to see if we're right. Well, here's the function we have inside it, 3 minus x. So the old x is 1. So 1 equals 3 minus x. And if we add x, we get x plus 1 equals 3. I get x equal to 2. And you did too. This is the new one. Very good. All right. Then for the other, we take this whole thing here is the same as the old y. So the old y is 2. Old y is 2. And we're going to say the new y is going to be negative 8 times f of x, which is the same as y, which is 2. And then we're going to add 10. So what's negative 16 plus 10? Can't add. Negative 6. So you got that one. Good. And that's translating a point. And so what we can do is if we have a crazy function that we want to do all this stuff to, we can just take 1, 2, 3, 4, 5 points and translate them. And I'm going to have you do that right now. So what we're doing, the class is going to come up with the translated x, y, and xy's, and then we will plot it, and then we'll see how it actually looks as a graph. Okay, so we have 2.5, 13.5. That's going to be, what is that, 6.5? That's going to be way up here. And then this is going to be 3 halves, 2. So 1.5 up 2. And then this one's going to be 1/2, negative 5 halves. 1/2, negative 5 halves. And then the next one is 2 again. And then this one's going to be up here. So what happens is we get this shifted, stretched, and flipped thing, and you didn't have to do anything with it. All right, so we talked about shifts before. For homework, you're going to do the drawings of these and shifting the points. So just kind of looking at these, you're just going to use the theorem and find a point on the graph that's shifted. So here's 2, negative 3. You're going to shift those. Have a good day. See you tomorrow. Not really, because we're going to PSAT test, right? Thursday we'll have that.